Hi everyone, welcome back to the workshop, and it's test instrument upgrade time again. And what you see in front of you is my Advantest R6581T 8.5 digit multimeter. Now I did produce a video not that long ago actually where I showed the upgrade of the VFD display to this OLED display that you see here. Courtesy of the reverse engineering EEV blog user, forum user called MickleT. And thanks to MickleT, he released the source code for the Blue Pill STM32 board that drives this actual OLED display here, that also sniffs the display board SPI interface in order to pick up the data that he could then convert for the new OLED display. And like I said, I did produce a video on that conversion of my own R6581T. However, I haven't stopped there. I took MickleT's code and I've actually modified it. I decided to see if I could actually drive a higher resolution, slightly bigger display. And this is it here. This is a 320 by 960 pixel resolution TFT LCD, so pretty high resolution, and as you can see it's quite a lot bigger than the original OLED. Not quite as big as the original VFD, but it pretty much fills this entire window, bar a centimeter at either end there. But in order to drive this TFT LCD, it's a lot different than driving the OLED display. Now, to drive a TFT LCD actually requires quite a lot of power in terms of processing speed, and there are one or two other users on the EEV blog forum that have done something similar and driven it via a much higher spec STM32 than the Blue Pill that I was already using with MickleT's conversion. So I decided to go down a slightly different route, and what I'm using is this display adapter board here. This is one that you can buy, and it's capable of driving via this connector here. It connects basically directly to the LCD here, and then you've got a user interface here which gives you a couple of SPI interfaces and a couple of logic pins as well in order to control the chip on the board there. And this is an LT7680A-R, and it has all the PLL and the P-clock, the H-sync, the V-sync, all the signals necessary in order to drive a TFT LCD direct, because you're talking up at 60 megahertz for some of the signals there. So I decided to use this, and I can drive this directly from the existing Blue Pill board, and just by modifying MickleT's original software. Basically ripping out the OLED driver side of things and replacing it with the code to drive this board here. So a quick look at the code, and here we are inside Visual Studio. And part of the matter is this packets to characters subroutine here. This is the SPI receive buffer. The code uses RX buffer to store the raw data from the SPI interface. The buffer captures packets structured to control the VFD display, and it's a 5x7 bitmap representing each character, and with a single bit that indicates the state of each annunciator. And this is where my code jumped in. I added this extra subroutine here, which will recognize each hex string. That's the 5x7. You can see there's 7 lines here. That's the hex data for each line in that 5x7 character. And my code here will recognize each line coming in and then convert that to a character, as you see down there. All the numbers, all the letters, a good few symbols, and everything in between. And then once that's done, this is where my code totally takes over, because I can now manipulate that character data and send it to the new TFT LCD. So what I did was create a new file, create a whole load of defines. As you can see here, there's quite a lot of setup required to drive a TFT LCD. Everything from the vertical back porch, the resolution and horizontal vertical pixels, whether the H-Sync and V-Sync signals are active low or active high. This is all to do with setting up that LT7680 IC. And then once that was done, I could start writing routines to actually send data to the actual LT7680 IC. And as you can see here in this file here, there's quite a lot of routines. The base routines, the core commands for writing to registers within the LT7680, for writing data, for reading back a status register, and everything else. And then at boot, what I've got here is a whole load of subroutines that run at boot, everything from the software reset of that LT7680 to setting up the PLL, setting up the SD-RAM inside the chip, and then sending all the setup commands for the Alexa horizontal back porch, etc. All those are sent across in order to get the chip all configured up. And then from there, it was a case of taking the character data, the ASCII data that I captured, and sending it to basically 3 different lines within the LCD that I'd configured. The annunciator line, the main line, and the auxiliary line. And that's what we've got down here. Here's where I'm writing to the main display, setting up the coordinates for the X and Y for the beginning of that line, and a few custom characters I needed to set up inside the LT7680. It's got 3 or 4 different character maps, but unfortunately the ohm symbol is not one of them. But luckily you're able to set up a custom character, and I needed to handle that here. Then you've got the auxiliary line here doing something very similar. And then the annunciators. As you can see, I've got them set up here in a small array. The position, the X coordinate of each one, so that I can indicate them individually. And then the code for doing that. And then I've got a small splash screen as well. Now it sounds simple enough, all of this, but I can tell you it took a few weeks to get all this bottomed out. Part of the problem was having never used LT7680 before. It took quite a bit to get that up and running. And in fact, I actually needed to go back to the manufacturer of the LT7680 Levtop in China, and they were absolutely brilliant, pointed me in the right direction with some sample code, and which I was able to decode and find out how things were working. Does the job rather nicely. However, what I also wanted to do was make this more or less a kit that was dead easy to install, and that's when I decided to design my own board here. The LT7680 board will attach onto there with a flat flex. The blue pill board will go up on here, the STM32, and that all the wiring's already in place. The LCD can just loop over the side there, connect onto the side of the LT7680, and basically you're left with 5 pins, power, and 3 signal wires that drop down onto the Advantest display board and pick up and sniff that SPI interface. Dead easy. And here's my board fully assembled. I've already written all the code, tested it. There was a short I released, a YouTube short, showing it up and running on the actual Advantest multimeter. So I'll link that down below if you want to see it. And you can see I've got the blue pill board there, a couple of decoupling caps, a header for selecting different colours on the actual LCD. And of course I've fitted the LT7680 board with a short flat flex here, and that'll mount on this single inline header here. So I've just finished assembling it to this stage, and I'm ready now to mount the LT board onto my board, solder it in place, and then fit it to the actual multimeter itself. However, if you're following along at home building up this board, because I will make the Gerber files available, there is one thing you do need to understand when mounting this board onto this one here. Now, the actual TFT LCD is not mounted directly in front of my board. If it was, it would be dead easy. We've got plenty of length here. Once the LT board soldered in place, just to loop up the side and plug into the side of the actual LT board. But it's not like that. The actual TFT LCD is actually mounted quite far off due to the position of the window. So the flat flex here has to come along and then loop round the end of the existing display board before it can plug into the LT board. So that doesn't give it a lot of length at the very end, even though this board is mounted as far that way as possible. So it actually matters that the height of this board here is down as far as it'll go, so that this flat flex here doesn't need to come up as far before it loops in to be connected. Now, I'm using a 6cm flat flex here, but you can use any length you like because it just gets folded up underneath the board there, which I'll do right now. So basically it just loops like that, and then there's a header here. There's 5 convenient holes on the LT board that are actually used to program this flash IC on the board, but we're not using that, so this is just an empty header here, and quite simply it'll mount just like that, and you solder it in place. Now, you will notice that I've got Kapton tape over the top of this connector here, and the reason for that is there's 2 metal pins at either end there, and the actual legs of the actual connector itself loop up, and they're actually exposed along the top there. And because I want this board mounted down as far as possible, it actually touches this connector, the underside of the board here, and I didn't want it to short out. I mean, there is a solder mask, etc., but I didn't want it to short out. I didn't want the flat flex there to short out either. So a little bit of Kapton tape before you mount this board, push it down as far as possible, and then solder it in place. So I'll away and do that now, and then we'll go on to the next stage. Now, there is a configuration change that you do need to make on the LT7680A-R PCB. There is actually 3 surface mount jumpers there, J1, J2 and J3, and I've actually written it on here. J1 must be open, J2 must be closed, and J3 must be closed. Now, J3 is closed by default anyway, but you will find probably that J1 and J2 are swapped. So you will need to go and open up J1 and close J2. Now, what that does, it reconfigures the board to use the 7680 to generate the PWM signal for the backlighting on the LCD through this connector here. In the other configuration, by default, you just have a pin on this connector here that the user can send their own PWM signal in to drive the backlighting. And I decided it was just easier to do it in software rather than have to worry about it in hardware. And there it is, soldered in place, all ready to go in. As you can see, looking at it from there, there's the entry on that connector for the flat flex. Now, you will notice that on the actual board here, I've got this little cutout here. And that's because this board here actually mounts quite close onto the existing display board on a couple of standoffs here. However, there's a capacitor, an electrolytic capacitor on the display board, and I didn't really want to remove it, that is tall enough that it comes up past, it's higher than this board needs to be. Remembering, I can't mount this board at any particular height I like, because of this length of the flat flex here. I want to keep this board here down as far as possible onto that display board. So I had no choice but to put a little cutout on this board to accommodate that electrolytic. Now the capacitor doesn't come up as far as this LT board. Well, I said that, however it's not quite true, because I've actually got two R6581T multimeters and both of them have different lengths of electrolytic capacitor, and unfortunately the second one I'm away to modify has got the taller one, so we're going to have to actually do something about that, i.e. replace that capacitor with a shorter one that can live underneath the LT board. So that'll be part of the modification I do need to make when we get to the multimeter itself. So this board's all ready to go in. Like I said, the only connections to it now are these 5 connections here down onto the display board. Now there is the back of the display board, and as you can see there is my original OLED conversion with the STM32 blue pill mounted on the back that I showed in my original video. And there is the wires, 5 wires coming up onto this one here as well, the power and the 3 signal wires there. And whilst we're here, there's that electrolytic capacitor that gets in the way. And like I said, this one's a little bit taller than the one in my other R6581T, so I will have to remove that one. It's questionable whether you could remove it completely. I'd probably advise not to, and the reason for that is it's across the 60 volt supply that goes to the VFD driver chips on that display board, and of course they're not actually getting used. I suppose technically they could probably be removed from the display board, but of course I want to keep this upgrade as simple and as easy to do as possible, so we're not going to do anything like that. The most intrusive thing we're probably going to do is changing out that electrolytic capacitor. And there is the original front side of my OLED conversion, so I'll just go away and remove all that off camera, including getting rid of this here. Don't really need to see this. Right, that's the OLED hardware all removed. I'm now ready to change out this capacitor here. It's a 47 microfarad 100 volt. Again, like I said, it's on that 60 volt supply. However, I couldn't find a shorter capacitor of the same value, but I have managed to find a 33 microfarad 100 volt readily available, and I'm going to put this one in its place, and we can get away with that because, like I said earlier, that VFD supply is not actually used. It goes to these ICs but doesn't do anything else. There's no output we're using from those ICs. Now the next thing that I want to do is mount this TFT LCD onto the back of the panel there in front of the window, and I do actually have some dimensions about where it should be placed. Now we can't mount it front and centre in the window because the flat flex just isn't that long, so it does need to shift that way a little bit. And I've come up with a dimension from the inside edge of this metal plate here to the edge of the actual display itself. You're looking at 42 millimeters. And also it needs to be positioned that way as well. And I've come up with a dimension that there should be a 2 millimeter clearance between this edge here and the inside edge of the top of that display panel there. So it should look something like that there. Now it will be held in place. I've got something for that. However, I thought it's easier to have this attached permanently, as it were, onto the display panel there, so that it's then easy to manipulate everything else without this moving around as such. And what I've come up with is a couple of strips of double-sided tape that'll just go down right along the edge there and down this edge here, and they will just lie up against the inside edge of that aluminium there, and they won't be visible because this display is actually quite a bit wider than the aperture there. And I've already prepared some of that double-sided tape. I've got it on quite a big reel, so I've just stuck it down onto this grease-proof paper here, so that it's easy to peel off and attach it. But of course, first things first, I've got to remove this front film from the TFT and avoid any fingerprints going forward. Now I'll take some of this double-sided tape and as long as it's reasonably close to the edge, right the way along, there it goes, and I can snip the end off. And same with the other side. The grease-proof paper that I'm using is actually a nice little handy tip. There it goes. Snip the end off. And there we go, capped on tape installed. So the next thing I'm actually going to do, I'm going to mark the 42mm point. Just a little marker pen, a little wee mark there. That'll give me a guide as to where to position the LCD. The 2mm, well, I can easily guess that. It's not that critical within, you know, half a millimeter or so. So here we go. Let's pull off the top of that double-sided tape. And this one here, if I can. There we go. Get rid of some of the dust. And let me just position that into place. And there we go. And that's it in position. Now you don't need to worry the fact that you can see past the LCD here, because it's so dark in the back of here, you don't actually see the ends of that LCD when it's in operation, when it's at full brightness, etc. You don't see it, so don't worry about putting any black card or tape or anything over there. It doesn't matter. Now the next thing is we want to mount the display board back into the display panel itself. We don't need to worry about the new board because it's going to be mounted on the back here. We don't need to worry about that just yet. Now as you can see, I'm working with these flat flexes connected all the time. A little bit inconvenient, but they do need to stay on for when you mount the display, my board, onto the back, because it actually covers part of the flat flex there, so you can't fit them later on. And I just chose to just leave them in place whilst I do this work. And it's actually easier if you put the display panel to the back of the meter and turn it this way rather than going the other way. So I'll go ahead and screw this into place. Oops, but before I forget, I did say earlier that we're not just going to rely on that double-sided tape to hold the LCD in place. We're actually going to put some foam across the top here, which will just lightly press down on the back of the LCD there to help hold it in place and stop it moving around. And here we go, we've got some single-sided adhesive foam here, and it's about 6mm thick and quite soft, should do the job nicely. There we go, I'll just stick it to the back of the LCD. Doesn't matter which side it goes on. And now I can drop the display board into place and screw it into place. And now we are actually ready to fit the new module here, as I'm now calling it. However, I'm not going to bolt it into place just yet. It's easier to actually attach the flat flex whilst the board's actually mobile. So lift the little tab on the connector there and then locate the ribbon, the flat flex, insert it and lock it down. I'll do that off camera because I need to get this down flat in order to do that. And there we go, that's it attached. So now what I can do is just maneuver the board into place, put a couple of screws in. Now you will notice that these flat flexes here will come down the back of the new board before they loop that way. So you will get a little bit of resistance from the flat flexes as you try to maneuver this board into place. And I'm actually going to use this M3 screws that I didn't use, that I removed from the display board, to attach onto the new pillars to hold the new board in place. And there we go, that's in place, all screwed up, and as you can see the flat flex still got a little bit of play there, and that comes down to that 42mm distance that we positioned the TFT LCD on the front panel there. It's really important, and I wanted to keep it as central as possible. I didn't really want to shift it all the way this way to give us loads of room. And you can see that electrolytic capacitor there. It is actually underneath the LT board, and it's not touching the underside of it, although it's just above the height of my new board. One more thing, there is actually a through hole pad at this end of the board, and that's just to put a single strand wire down through there and onto one of the solder pads on the board. You can see the backs of these switches. There's 4 sort of pads per switch. Just use one of them to anchor this board, this end of the board here, and nice and level there like that, down onto one of those pads. So I'll go and do that now. Right, that done. The next thing is the 5 wires. Now, as you probably saw at the start, 3 of the wires are round about here. The other 2 is the 5V pickup, and that's just right there. And luckily this board doesn't extend over the top of where we need to solder. We've got the 0V and 5V connections right there. So I've got a diagram for that, a PDF I'll make available down below, as with everything else. So I'll go away and make up that wires and attach them and wire it into place. And that's the wiring done. Now I've just gone ahead and used Kynar wire. That's 30 AWG wire wrapping wire, which I use for all my prototyping. That's more than good enough for those signals. And I've just used some multi-strand 7 core 0.2mm for the 5V supply there. Probably could have got away with the Kynar as well, because it's actually quite a low current consumption, this setup here, but there's no harm in just stepping up a little bit for the 702 wires. And that's it. We're ready for a power up, believe it or not. So let me reposition the display so that we can see it, and let's put power in and let's see if we get a nice display. Okay, so let me just tilt this back slightly so you can see it head on. And let's just put power on. There we go. Yes! It's working! Brilliant. Now, as you can see, it's positioned quite nicely vertically, and it's only slightly towards me horizontally in that direction. You wouldn't really notice it much. It's more than you would think, but it's not too bad. And the menus should all still work. There we go, a nice TFT high resolution LCD on the R6581T. So all that remains now is just to fit the front panel back on, put the case on, and we're done. So I'll go ahead and do that now. And before I put the case on, let's just take a look in the back there. You can see the STM32 blue pill there, plenty of room for it, and the LT7680A-R, that just fits in there, no problem. The metal framework of the actual chassis of the meter itself comes up just about to where the flat flex disappears down below, and so it just fits in and no more there. And the same with everything else round about it. It's positioned to a T. And if you do want to remove the blue pill in order to do some software upgrades, anything like that, then you can actually remove it. This particular one I've got on those sockets, so it's easily removed. The flat flexes here do get in the way a little bit, but it's not impossible to just get your fingers in there to remove it and to refit it again. So there we go, that's it all boxed up and working, and everything's working perfectly. And now we've got, in this case, a 3-color display. Absolutely beautiful, transforms the use of this R6581T. I'll also link to my Git where all the source code lives for the blue pill STM32, but I'll also link to the hex file as well so that you can directly program that using the ST-Link software. Now this has been a really enjoyable project to do in the workshop. I really enjoyed getting the LT7680A-R converter board working, the driver board, a lot of software work. I've written thousands of lines of code to get that working, as you'll see if you do decide to download the source. Now I did actually use Visual Studio for the programming. Now that wasn't what MickleT was using, but I've managed to convert his C code so that it will install and compile etc. all within Visual Studio. So the whole project basically is available on my Git. Because there is one or two other test instruments that I do want to convert as well to a TFT LCD. And now that I've got it all in Visual Studio with the drivers basically written to drive these LCDs, I can easily adapt it to different shapes and sizes, etc. So thanks for watching, and remember you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. Links below to my website, and for those who prefer Odyssey, check out my channel there. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.